There was a genetic disease running through Queen Elizabeth II's own family bloodline that killed princes, brought down an empire, and could have ended her family's grip on the throne completely. And by pure genetic chance, it missed her by one single generation. Before we get into exactly how close it came, hit subscribe right now, because this is one of the strangest true stories in modern genetics, and it explains something else too. Why Elizabeth herself lived to be 96 years old, while other members of her own family were dying young for over a century before her. Let's go back to where this all starts, because you cannot understand Elizabeth's story without understanding her great-great-grandmother, Queen Victoria. Victoria ruled the United Kingdom through most of the 1800s, and somewhere in her own body, likely through a spontaneous genetic mutation, meaning it appeared out of nowhere with no known history of it in her parents' families, she was carrying a mutation in a gene responsible for blood clotting. The condition is called hemophilia, and it stops blood from clotting properly, meaning even a small injury, a small cut, a small bump can turn into uncontrollable, sometimes fatal bleeding. Victoria herself never showed a single symptom. Women who carry this specific mutation almost never do, because the gene sits on the X chromosome, and women have two X chromosomes, so a working copy from one parent usually covers for a faulty copy from the other. But every time Victoria had a child, there was a real mathematical 50% chance she would pass that mutation on, and if that child was a son and he inherited it, he would have no backup copy to protect him, because sons only get one X chromosome from their mother. There is no fixing it and no covering for it. He would have the disease. Queen Victoria had 9 children. Her youngest son Leopold inherited the mutation and lived his entire childhood as what doctors at the time literally called a bleeder. He bruised from almost nothing. Small falls could turn into medical emergencies. He died at just 30 years old after a minor fall caused a bleed in his brain. 2 of Victoria's daughters, Alice and Beatrice, were confirmed carriers, meaning they did not have the disease themselves, but were passing that same 50% risk onto their own children every time they gave birth. And because European royal families spent 2 centuries marrying each other across borders to cement political alliances, this single mutation from one woman spread directly into the royal houses of Germany, Spain, and Russia. It became so infamous among royalty across the continent that historians and doctors gave it a nickname that is still used today: the royal disease. The most well-known case is the Russian royal family. Victoria's daughter Alice passed the mutation to her own daughter, who became Empress Alexandra of Russia after marrying Tsar Nicholas II. Their only son, Alexei, heir to the entire Russian throne, was born with hemophilia. His mother's desperate attempts to manage his condition, including bringing in the mystic Rasputin, who claimed he could help the boy when official doctors could not, are widely credited by historians as one of the factors that destabilized the Russian monarchy in the years leading up to the revolution that ended it completely, and eventually led to the execution of the entire family in 1918. In Spain, Victoria's granddaughter Eugenie married King Alfonso XIII, and 2 of their sons inherited hemophilia. One of them, heir to the Spanish throne, bled to death at 31 years old after what should have been a minor car accident. His younger brother died the same way, from internal bleeding after another car accident, at just 19. In Germany, the mutation showed up again in Victoria's grandchildren through her daughter Alice's other children. So here is the question that actually matters for our story. Why did this devastating genetic mutation completely bypass the family line that eventually produced Elizabeth II? The answer comes down to pure, cold genetic chance. And it is honestly one of the cleanest real-world examples of how random inheritance actually works. Queen Victoria had 4 sons. Only one of them, Leopold, inherited the mutation. The other 3, including Edward VII, who was next in line for the British throne after Victoria, did not inherit it at all. Since a father cannot pass an X-linked condition like this to his sons, meaning he gives his sons a Y chromosome, not the X chromosome that carries the mutation, and since Edward VII himself was never a carrier in the first place, the entire line of British monarchs descending directly from him, all the way down to George V, then George VI, then Elizabeth II herself, was never at any real genetic risk. The mutation traveled sideways into Germany, Spain, and Russia through Victoria's daughters, and it devastated those branches of the family for decades. But the direct line to the British throne, purely by the coin flip of which of Victoria's children happened to inherit which copy of which gene, came out completely clean. That is not something anyone in the 1800s could have known or planned. Nobody understood chromosomes yet. Nobody could test for this. The safety of the British monarchy from one of the most devastating inherited diseases in royal history came down to nothing more than which version of a single gene randomly ended up in which one of Victoria's children. Had that mutation landed in Edward VII instead of Leopold, the entire 20th century history of the British royal family, and quite possibly the stability of the monarchy itself, could have looked completely different. Now let's talk about the other side of Elizabeth's genetics. the side that actually explains why she lived so long, because this part of the story is just as interesting, and it is backed by real, current longevity research. Elizabeth died in September of 2022 at Balmoral Castle in Scotland at the age of 96, after a reign of 70 years, the longest of any British monarch in history. Her own mother, known to most of the world as the Queen Mother, lived to 101 years old, dying in 2002. That makes her the second longest living member of the British royal family in recorded history at the time of her death. Longevity researchers who have studied Elizabeth's case point out something specific and measurable. Genetics accounts for roughly 20 to 30% of how long a person lives, according to widely cited research summarized by scientists like Andrew Steele, a scientist who has written extensively on the biology of aging. That means the majority of what determines lifespan, somewhere around 70 to 80%, comes down to lifestyle, environment, and plain luck, not genetics alone. But here's the important detail researchers add. That 20 to 30% genetic contribution becomes dramatically more important the older a person gets. For most people, making it to your 70s or 80s is mostly about lifestyle. But making it into your 90s, and especially crossing into triple digits like Elizabeth's own mother did, is where genetics starts to matter enormously more, because your body needs specific biological advantages to keep functioning at that age, regardless of how well you lived. This is backed up by a well-established finding in longevity science. One of the single strongest predictors of how long you will live is how long your parents lived. Elizabeth's mother reaching 101 is, according to researchers studying her case directly, a significant piece of evidence that Elizabeth herself inherited genes associated with exceptional longevity. Her father, King George VI, is the outlier in this story, dying at just 56 years old, but his early death is well documented as being linked to heavy lifelong smoking and lung cancer, an environmental and lifestyle factor, not a genetic one. When you look at Elizabeth's overall family picture, a mother who lived past 100 and a father whose early death is explained by a specific external habit rather than inherited disease, the genetic story leans heavily toward her having inherited a strong biological foundation for aging well, layered on top of the disciplined, active lifestyle she was widely known for. And that lifestyle is worth walking through because researchers studying healthy aging consistently point to Elizabeth as a real-world case study. She walked with her dogs daily. She rode horses well into her 80s. She kept a light, simple diet, with her former royal chef describing her lunches and suppers as consistently modest rather than heavy. She stayed socially and mentally engaged through constant public duties, right up until just months before her death. Researchers studying aging populations have repeatedly found that regular, low-intensity movement, strong social connection, and a sense of ongoing purpose, sometimes referred to using the Japanese concept of ikigai, meaning your reason for getting up in the morning, are all independently associated with longer, healthier lifespans in elderly populations. Elizabeth, whose formal duties as head of state gave her structured purpose literally every single day of her adult life, right into her 90s, fits this pattern precisely. Now, her son, King Charles III, becomes an interesting case to watch through the same genetic lens, and researchers have said so directly. His mother lived to 96. His father, Prince Philip, lived to 99, dying in 2021. Longevity researchers studying the family have pointed out that with two parents, who both lived into their late 90s, Charles is genetically positioned for a potentially long reign himself, even though he began it later in life, at 73 years old, than any monarch in British history. Before we move on, it's worth going back even further because Victoria's hemophilia mutation is not the only documented genetic mystery in this family's history. Nearly a century before Victoria was even born, her grandfather, King George III, the same king who was ruling Britain during the American Revolution, suffered from repeated, severe episodes of what was described at the time as madness. He experienced confusion, agitation, and periods where he was completely unable to function as king. Episodes severe enough that Parliament had to formally debate installing his son as regent to rule in his place. For nearly 2 centuries, historians simply assumed this was a form of mental illness. But starting in the 1960s, a group of medical researchers proposed a different explanation entirely, a rare genetic blood disorder called porphyria, which affects how the body produces a molecule called heme, an essential component of the protein that carries oxygen in your blood. In severe episodes, porphyria can cause exactly the kind of symptoms historical records describe in George III, including confusion, agitation, and even discolored urine, which several accounts from his own physicians at the time specifically noted. It's important to be fully transparent here, because this is a genuinely contested area of medical history, not a settled fact. Some modern researchers, who have re-examined the historical records in more detail, have pushed back on the porphyria theory, suggesting the king's symptoms may be better explained by a psychiatric condition such as bipolar disorder instead, and the debate among medical historians continues today without a definitive resolution either way. What we can say honestly is this: whether it was porphyria or a psychiatric condition, George III's case sits at the very root of this same family tree, generations before Victoria, and it shows that questions about inherited biological conditions have followed this particular royal bloodline for longer than most people realize. Let's go back to Alexei in Russia for a moment, because his individual case shows just how severely this specific mutation could affect a single child. Alexei began showing symptoms of hemophilia within months of his birth in 1904, and by early childhood, ordinary bumps and falls that would mean nothing to most children were causing him internal bleeding that left him in agony for days or weeks at a time. His mother, Empress Alexandra, who inherited the carrier status directly from her own mother, Victoria's daughter Alice became increasingly desperate for any treatment that could help her son, since 19th and early 20th century medicine had no real answer for hemophilia at all. This desperation is what opened the door for Rasputin's influence within the Russian royal court, and historians studying the fall of the Russian monarchy consistently point to that influence, and the secrecy surrounding Alexei's condition as meaningful contributing factors in the broader political instability that eventually led to the revolution and the family's execution in 1918. It is a striking historical example of how a single inherited mutation in one child did not just affect that child's health. It arguably helped reshape the political future of an entire country. Now, back to the longevity side of this story, because there is more recent science worth including here too. Researchers studying human aging have identified specific biological markers that separate people who live into their 90s and beyond from those who do not, and one of the most studied is something called telomere length. Telomeres are small protective caps found at the end of each strand of your DNA, and every time a cell divides, these caps get slightly shorter. Once they become too short, cells stop dividing properly, which is one of the underlying mechanisms behind aging at a cellular level. Some individuals are simply born with longer telomeres than others, largely due to inherited genetic variation, and multiple studies have found that people who reach extreme old age tend to have longer telomeres than the general population, even accounting for lifestyle differences. While no public research has ever measured Elizabeth's own telomere length directly, for obvious reasons, researchers studying exceptional longevity in families where multiple members live past 90, exactly the pattern seen between Elizabeth and her mother, consistently point to inherited telomere length as one of several likely contributing biological factors. Another area researchers point to is something called cognitive reserve, which refers to the brain's ability to keep functioning normally even as some natural expected decline happens with age. People with higher cognitive reserve, often built through decades of continuous mental engagement, complex work, and social interaction, tend to show fewer visible signs of cognitive aging even into their 90s. Elizabeth's daily schedule for essentially her entire adult life involved constant meetings, briefings, official correspondence, and public engagements that required sharp, active decision-making right up until the final months of her life. Researchers studying healthy aging populations have specifically identified this kind of sustained, structured mental engagement as one of the strongest known protective factors against cognitive decline in old age, regardless of a person's underlying genetics. Let's talk honestly about how Elizabeth's own life actually ended, because there has been real, documented confusion around this that is worth clearing up properly. Her official death certificate, released by the National Records of Scotland, listed her cause of death simply as old age. That is a legally permitted cause of death in the United Kingdom for someone of advanced age, when no single dominant condition is identified as the primary cause. However, multiple people close to the royal family have since come forward with additional detail. Giles Brandreth, a broadcaster and biographer who was a personal friend of both Elizabeth and Prince Philip, wrote in his biography of the Queen that he had heard she was dealing with a form of myeloma, which is bone marrow cancer, in the final year or so of her life. He connected this directly to the tiredness, weight loss, and mobility issues that were quietly reported by the palace throughout her last 12 months, without ever naming a specific medical cause at the time. Separately, former British Prime Minister Boris Johnson wrote in his own memoir that he had been told, roughly a year or more before her death, that she had a form of bone cancer, and that her doctors had warned she could enter a sudden decline at any point. Multiple myeloma, for context, is a cancer that begins in the bone marrow, the soft tissue inside certain bones that produces the body's blood cells, and it most commonly affects older adults, frequently causing exactly the kind of bone pain, fatigue, and gradual physical decline that palace statements vaguely referenced throughout 2022 without ever confirming a diagnosis publicly. It is worth being clear and honest here that neither Buckingham Palace nor any official medical source has ever formally confirmed a myeloma diagnosis. What we actually have is the official cause of death, old age, alongside consistent, independent accounts from two separate people close to the family describing a bone marrow cancer diagnosis that would fit the documented symptoms perfectly. That is a meaningful distinction, and being upfront about what is confirmed versus what is reported secondhand is exactly the kind of honesty that keeps a story like this grounded in fact, rather than speculation. There is one more piece of the genetic puzzle in this family that deserves mention, because it connects directly back to the hemophilia story from earlier, and it shows how differently things could have gone. Beyond Britain, the hemophilia mutation that Victoria passed down effectively vanished from royal bloodlines by the mid-1900s, mainly because so many of the men who carried it died young, in several cases from something as ordinary as a small car accident, before they had the chance to have children of their own who could carry the mutation forward. Modern genetic testing has since confirmed the exact molecular nature of the mutation using DNA extracted from the remains of the Russian royal family after they were identified through mitochondrial DNA sequencing decades after their deaths. That research confirmed the family was dealing with a specific type of hemophilia known as hemophilia B, a defect in a particular clotting protein called factor IX. It is one of the clearest examples in medical history of scientists reaching back over a century later using modern genetic tools to finally solve a mystery that royal doctors in the 1800s had no ability to even properly diagnose, let alone explain. It's worth briefly finishing the story of the Spanish branch of this family too, because it shows how this single mutation kept resurfacing in different countries for decades after Victoria's own death. Her granddaughter Eugenie carried this mutation into Spain when she married King Alfonso XIII in 1906. Two of their sons were affected. The elder, who stood to inherit the Spanish throne, died at 31 after a minor car accident caused internal bleeding. Doctors could not stop. His younger brother died the same way, from a different car accident at just 19 years old. Neither left an heir, meaning that specific line of the mutation ended with them. Eugenie's two daughters were also studied by later generations of doctors and historians as possible silent carriers, though, as it turned out, none of their own descendants ever developed or passed on the disease, effectively closing that chapter of the mutations spread through Spain entirely. In Germany, a similar pattern played out through other descendants of Victoria's daughter Alice until, by the middle of the 20th century, modern medical historians recorded the last confirmed hemophiliac descendant of Victoria dying in 1945. Nearly a full century after Victoria herself was born. The mutation that once terrified royal families across an entire continent simply ran out of carriers to pass itself on to. Put all of these pieces together, and you get a genuinely remarkable picture of one bloodline carrying two completely opposite genetic stories at the same time. On one side, a devastating mutation that Victoria unknowingly carried, one that ended up killing princes across 3 different countries, destabilizing an empire in Russia, and shaping the entire course of 20th century European royal history, simply because of which of her children happened to inherit which copy of which gene. On the other side, sitting in the exact same family tree just a few branches away, a completely separate set of inherited traits tied to exceptional longevity, the kind that allowed a woman born in 1926 to still be actively performing her duties as head of state 70 years later, at an age when most of her own ancestors and most people in general had long since passed away. Elizabeth II never carried the mutation that devastated so much of her extended family across Europe because of a genetic coin flip that happened generations before she was even born. What she did inherit, most likely from her own mother's side of the family, appears to have been a biological foundation built for a long life, one she then reinforced for nearly a century through daily movement, a modest diet, and a sense of daily purpose that never really stopped until the final months of her life. 2 entirely different genetic stories, sitting inside the same royal bloodline, one that could have changed the entire future of the British monarchy if a single gene had landed in a different child 200 years ago, and one that quietly gave the world's most recognizable monarch 70 years on a throne that very nearly, through no fault or choice of her own, might never have been hers to inherit at all. What makes this whole story even more remarkable is thinking about it through a modern lens. Today, genetic carrier testing is a routine, widely available medical tool. Any woman today with a family history like Victoria's could take a simple blood test and know with certainty whether she carries a hemophilia mutation, long before she ever has children. Doctors could identify affected pregnancies early and prepare accordingly. None of that existed in the 1800s. Royal families were making marriage decisions that would shape the future of entire nations with zero understanding of the invisible biology sitting inside their own bloodlines. Oh, Queen Victoria never knew she carried a mutation that would go on to kill grandchildren she loved and help destabilize an empire she had never even visited. It took modern DNA sequencing technology, applied over a century later, to the exhumed remains of the Russian royal family, to finally give scientists a complete, accurate answer to a mystery that shaped so much of European royal history. That gap between what royal families in the 19th century could see happening to their own children and what they actually understood about why it was happening is really the whole story here. Elizabeth II lived a long historic reign in part because of a genetic coin flip her family could not see coming and would not understand for another 100 years. And it is only with today's science that we can finally look back and explain exactly why. If you want more true stories like this, where real genetics quietly shape the biggest moments in history, make sure you are subscribed, because there is a lot more of this coming. Let me know in the comments which royal or historical figure you want broken down next. We read every single comment. Thanks for watching, and we will see you in the next one.